You have a higher heat addition because you make a more high temperature, network increase, heat input increase, high moisture quality during the turbine last stage, right? Because here, four three here has more higher moisture quality compared to 4 here. But yeah, temperatures, you cannot just increase the temperature up to your liking. I mean, like in the video it says that you need to be like less than 600, more than 600. I mean, yeah, the material, any material wouldn't stand more than 600 degrees Celsius. And another one is increase the boiler pressure, right? Increase the boiler pressure. So here in the case, you have an increased work net output, higher heat addition temperature, and low moisture quality during the turbine last stage. Right, so this you increase the boiler pressure. So you have increase the work net. So increase the work net, then the efficiency of the cycle increase. Okay, so any question? So these are the 3 things that we can change our cycle or modify our steam plant in order to increase the efficiency. Okay, so if no question, we move on to the example here. So effect of boiler pressure and temperature on the efficiency. All right, so yeah, we consider the steam power plant that we have solved earlier. So enters the turbine at 3 megapascal, 350 degree, the same as the previous example. But now we're lowering the pressure. So we lower the pressure instead of 75 kilopascal. We lower the pressure at 10 kilopascal, so much lower than the example before. So what's going to happen to the thermal efficiency of this power plant? Right. So we get the A first, and B, if now we increase the temperature of the boiler, so superheated up to 600 Celsius instead of 250, what will happen? And the thermal efficiency, if the boiler pressure now is increased to 50 megapascal, what will happen to the efficiency? So we look at A first. So in this case, now we have the condenser pressure is being low up to 10 kilopascal. So here, what happened to A? If now the pressure of the condenser is being low to 10 kilopascal. Okay, we look at the A first. And to find the thermal efficiency of this cycle, so we use again the efficiency formula. Efficiency equal to 1 minus Q out over Q in. That's what we're going to solve. So first, and solve Q out and Q in, we need to find the property, the enthalpy H1, H2, H3, and 4. This is what we're going to do, solving for H1, H2, H3, and 4 first. So yeah, we have to go through the cycle, start for state 1. So this is known 10 P1, 10 kilopascals of liquid. So this you can find this on your table A5, and state 2, so P2. S2 equal S1, and you can solve that here. Work pump in equal to the VP2 minus P1 here, and find find the work pump in, and with that you can solve for H2, which is H1 plus the work being input into the pump. For H1, H2, now we solve for H2 and H4, right? So this the same method that we solved in the previous example, so same. So it's nothing new, right? Nothing new as well. I mean, you have seen this approach in your thermodynamics 1, right? So once you solve for H1, H2, and H4, you can solve for Q in, Q out, and you can find the efficiency, right? 1 minus Q out over Q in, and we'll see that is 33.4%. So remember, previous example, we solved that for Rankine cycle, the efficiency was 26%. Now, when you lower the pressure to 10 kilopascal, now the efficiency has gone up to 33.4%. Okay, so let's see what happened now in B. So in B now, we want to increase the efficiency more. The steam is superheated to 600 degrees Celsius instead of 350 degrees Celsius. So if you look at the TS diagram here, from 250 degrees Celsius is dragged up to 600 degrees Celsius. So what will happen? So what is the efficiency now from A to B? So this is what we are going to solving the efficiency for B. So now the state 3 will be 600 degrees Celsius. Right. State 1 and state 2, you solve the same as the A here. So this value will be the same. Only change is state 3 where T3 now is 600 degrees Celsius. So state 3 megapascal 600 degrees Celsius. So you look at the superheated table A6. You look at the H3 will be 3682.8, and then state 4, yep, it will be in the saturated region, 10 kilopascal, and okay, this S3 equal to S4, right? S3 to S4, and solve that for same method. We have to solve for the quality first, right? 0.915, and once we solve the quality, you can solve for the H4 equal to the HF plus the quality 4 times HFG, and there you go, you will have this H4. Now we're going to see the efficiency. So solve for Q in, Q out. The efficiency, all right, when you increase the temperature, would be 37.3%. So now it's being increased. It increase more when you increase the temperature of the superheated regions. It's now at 37.3%. Okay, now we go back to C. So C, now we want the boiler now is the boiler pressure is being raised to 15 megapascal, while the turbine inlet temperature is maintained at 600 degrees Celsius. So what will happen? So it means that from B here, you want to change to the boiler, or the pressure here is being raised to 15 megapascal. So from 3 megapascal here, change up to here. So temperature remain the same, 600 degrees Celsius. So from B, now you want to increase 3 megapascal up to 15 megapascal here. What will happen to the thermal efficiency? So this we want to see that. So for B, for C, so state 1 will be the same because the property is the same as others. But now at the state 2, you have a 15 megapascal and S2 minus S1. Right, state 3, 15 megapascal, 600 Celsius, and state 4, 10 kilopascal. The TB matter. Right, so yeah, so just gone through the approach that we have solved just now. So H2, right, solving the work pump in, everything. Find the work pump in first, and then H2 can be found by the equation of the work pump in, and H3 as well. So H3 is the superheated region, so you have to look at the table. Superheated region with the pressure, right? So pressure now is 50 megapascal, and H4, right, is determined by similar manner. You have to find the quality first, and then once you know the quality, then you can find your H4. We solve for Q in and Q out, and solve the efficiency, and you see that the efficiency now is being increased to 43%. Right, so this is what happened if you lower down the pressure of the condenser, increase more, and then you increase the superheated region temperature, increase more, and then now you increase the pressure of the boiler, you increase it more further. So the efficiency now is 43%. Instead of the normal idle cycle, is range around 26%. So now increase to 43%. Okay, so here's an observation. So the efficiency increases, right, from boiler pressure 3 to megapascal, while maintaining the turbine inlet at 600 degrees Celsius. However, the quality of the steam, right, quality, as you know, is the mass of the vapor over the total mass of the working fluid, decreases from 91.5 to 80.4%. So moisture content is increases from 85 to 60.1. Right, so quality is the mass of the vapor divided by the mass of the total mass of the working fluid. Right. Okay. Okay, so any questions so far? All right, so the approach, the calculation here, I mean, it's nothing new to you. Right, calculation nothing new to you. Is what you have solved in thermodynamics 1. Only difference that the cycle here. So this is a new cycle to you, the Rankine cycle, and then this tree effect here, which increases the efficiency here. The cycle is new to you, but the approach here, I mean, all this nitty gritty here, I mean, so you have learned that in thermodynamics 1, right? So you're So the next week there will be no tutorial, right? So next week there will be no tutorial. Class will be offline. So, but well, I will post up this tutorial question online. So you can try out the question of tutorial for this, right? And yeah, as usual, I mean the answer are given. So yeah, you just have to attempt it and try to solve the question. Okay, so try this one. It's a 2-minute paper using Office 365 form. Okay, so this is just a question. We're going to see this question here. So which of the following here are not true when splitting is not true? Okay, so which following here is false when splitting steam to a higher temperature? So which one is false? So A, pump work input remain the same. So here in this case where we increase the this steam up to superheated region. I mean, so yeah, for B here, what will happen to this the cycle here? We increase the from T3 further here up to here. So this is what the question asks here. Which one is false? Oh yeah, just make it simple. True or false? So true or false? Pump work input remain the same. So increase the temperature at you increase the T3 temperature. Pump work input remain the same. Yes, right. So it is correct. Pump work input remain the same, right? So because your pump is 1 to 2, you just increase 3. Turbine work output increases, right? So at T3, turbine work output increases. It increases, right? Because you increase the energy of the T3. So yeah, it's true. And heat supply increases, T3. Yeah, increase the T3. Obviously, the heat supply, heat in will be increased. Heat rejected remain the same. You increase the T3. Right, so provide the same. Yeah, heat rejected remain the same. Cycle efficiency increases. Yes, it will increase. Moisture content of the turbine exit increases. Right. Yeah, like we see in the example, moisture content increases. The moisture content increases from at the end of the increment of the steam. Okay, so that's the effect of increasing the efficiency using the 3 methods that we just solved just now. Right, so any questions so far on this? Okay, so if no question, then we adjourn our class today. Right, so I've already uploaded the slide online. And please make sure that you have signed up your attendance on Power Apps. Right, so again, there will be an online assignment. We post up on Ulearn, so yeah, by your grader, but I've yet to receive that. And then yeah, we will start lab on week 6 after your Chinese New Year. So next week there will be no class, but there will be an offline class. I will upload the video online and then also the tutorial as well. Okay, so thank you very much. So have a good holiday, those of you, and yeah, happy Chinese New Year for those who celebrate Chinese New Year. And yeah, please be back in UTP in this good shape. Okay. All right. So thank you very much. Assalamualaikum.
Thank you, sir.
Yeah, thank you.
Thank you, sir. Happy holiday.